Our unique proposition is that actually we're the first time integrating not only the protein extraction, but we're also integrating the agricultural side. We've switched the sprawling plant architecture into a bush-like architecture. This means that it stands tall, doesn't fall down to the ground, and then its period of from the moment you sow it until the moment you can pick it, you can harvest that. It's a very short period, about two months instead of 100 days. So it's an excellent crop for rotation.
This is Green Up, and today we are talking with Alon Karpol, CEO and co-founder at Better Pulse.
When we're talking about the plant protein, we're mainly talking about grains. The four main grains that we use today are corn, rice, maize, and wheat. Those are the main grains that you can use to extract the protein. Each grain has its own specific process. The majority part of the soy is being produced for oil. So there's anywhere between 50 to 30% of oil content in the soy. So when you're looking for soy protein, usually it's the byproduct of the soy oil. So the process is pretty intensive in terms of chemicals and energy. For rice is again an excellent source of protein, but rice it requires a lot of water for irrigation. So you have paddies and you flood them with water. That's not a very sustainable. You have to have a lot of water to raise rice.
So you have chosen black-eyed peas to develop your solution. What can you tell us about this grain?
One major limitation that made us aware that we need to think about black-eyed pea is to all of those crops bred through the centuries. So they need specific amount of heat, they need a specific amount of water, and that during the last decades we've been blessed with good weather and good conditions, and we have plenty of water. But it seems like everybody's talking about global warming and climate change, and it's going to happen. It's actually happening right now, and those crops are not adapted to the change that is coming. Soy, for example, would suffer from anywhere between 20 to 30% reduction in crop yields in the next decade. Those crops are not adapted for warm, dry climates. In order to strengthen the resiliency of our food supply chain, we're thinking about, let's start to look for crop that is already adapted for dry and warm climate and see if it fits. After reviewing different kinds of crops, we found out that black-eyed pea, cowpea, actually is an excellent candidate. And why? First of all, it's been cultivated for probably more than 5,000 years. It's coming from the Sahel regions, just south of the Sahara. So obviously, this is a hot region with minimal amount of water. Not only that it grows well under hot climate and minimal water, it also produces a very nutritious grain. The grain contains anywhere between 25 to 35% of protein, which is really high. I think the only one that competes with is soy. On top of that, there is no oil or a little bit of oil inside the grain, so you don't need some kind of exquisite or elaborated extraction methods. Turns out, when we extract the protein out of the grain, we're getting a really nice protein concentrate, which has very little aftertaste, and it's a really white powder. The white powder is an excellent candidate for different alternative dairy products. For example, yogurts, milks, or ice cream or creamers that could be incorporated really well and provide another way to diversify our supply chain. When you diversify and you bring some new crops that are already adapted for global warming, then you can increase the food security. So we think that we're two birds in our hands. First of all, we can secure food supply chain, make it more resilient, but at the same time, we're not compromising on taste or nutrition.